Okay, so up until now we've looked at the fact that the ionic oxides tend to form alkaline solutions, which means they will react with acids, and that the non-metal oxides, or the covalent oxides, tend to form acidic solutions, which means they're going to react with bases, and that's what we're going to look at today. We're going to look at how those react. So the first thing we're going to look at is the metal oxides with the acids first, and this is no different from what you've done at GCSE before. A metal oxide reacts with an acid to form a salt and water, and then you need to go back and balance it using macho. And that will work for all of these, whether it's sodium oxide, magnesium oxide, or aluminium oxide. The non-metals, however, they require a little bit of thinking about. I mean, the reactions are here, which you can, if you want, you can just learn all of those reactions here. However, there is a way of thinking about them which can certainly help you get through these. Now, I'll deal with aluminium oxide and silicon oxide in a little while. I want to deal with the ones that are probably easier for us to think about. So I'm going to start by looking at SO3. Now, if you remember in the previous section, we said that SO3 first of all reacts with water to form H2SO4, and that's the way to kind of think about it, that the SO3 is firstly reacting with the water that the sodium hydroxide is dissolved into, and then once that is done, or once the sulfuric acid has been formed, the sulfuric acid then reacts with the sodium hydroxide to form sodium sulfate. Don't forget to make sure that you get the formula correct by balancing the ions, and we get water left over. So if I kind of cross out all of the bits that we haven't kind of used in here, we can get rid of that, and then what we're left with here is the SO3 reacting with sodium hydroxide to form sodium sulfate and water. And then as soon as you've got that, it's a case of going through and balancing it. And of course, you're going to need 2 NaOH to balance the 2 sodiums in sodium sulfate. We'll look at the next one. I'll just get rid of all of that, so I've got room to kind of jot everything down here. So we're going to look at SO2 next, and we're going to look at it in exactly the same way. In the previous section, if you remember, we said that SO2 here will react with the water like this, which gives you H2SO3, and then from there, once the acid has been formed, it will now react with the sodium hydroxide. So H2SO3 plus sodium hydroxide will form sodium sulfate and water. And again, we just go through and remove all the bits that has kind of happened in the stages. So the SO2 has reacted with the water to form H2SO3, and then the H2SO3 has reacted with sodium hydroxide. So what we do then is we say, okay, well, the SO2 reacted with sodium hydroxide to form sodium sulfate and water, and then we need to go back and balance it just to make sure that everything matches up there. So that's the SO2 done. So just continuing with the working backwards of all of these, we'll have a look at phosphorus now, or the oxide of phosphorus, P4O10. And again, we just go through with what we've done before. So P4O10, first of all, it reacts with the water that the sodium hydroxide is dissolved in, which is going to give you phosphoric acid, H3PO4. as the phosphoric acid is formed, H3PO4, it then reacts with the sodium hydroxide, which is going to give you the salt, so Na3. Let's try that 3 again. Na3PO4 plus water. If I get rid of the bits that I've kind of started with, so the water reacted with water to make H3PO4. The H3PO4 then reacted with the sodium hydroxide, which basically leaves me with P4O10 reacting with sodium hydroxide to give me sodium phosphate and water. And all you need to do then, I say all, is to go through and balance it. So you need 4 of those, 12 of these, which will then give you 6 waters, which is what this reaction is here. Okay. The rest of them, or the other two, the aluminium oxide and the silicon dioxide, I'll do within a minute. Let me just clean this off again. So with the silicon dioxide, this is a case of really you just have to learn that it is going to make sodium silicate, or Na2SiO3. Now, I'm just trying to show you ways of trying to remember these, that if you think of SiO3, silicate, silicon's in the same group as carbon, so CO3 is the carbonate, that has a 2- charge, which means the silicate is also going to have a 2- charge on here. So when you kind of put the two together with your sodiums there, you're going to need 2 sodiums to kind of cancel all of these charges out that we've got here. And that gives you the sodium silicate, which we've got here. And again, from there, you're just balancing. So you've got silicon dioxide, sodium hydroxide, which gives you sodium silicate and water. The last one, the aluminium one, I'm going to deal in a lot more detail a little bit later on in the next one. But for now, the best thing I can say is you've always got to learn that it will form sodium aluminium hydroxide. Let me try that again. There we go. Sodium aluminium hydroxide. And just to kind of put this into context, we've got aluminium, which has a 3+ charge. We've got sodium with a 1+ charge, which means the number of hydroxides I'm going to need is 4 in order to cancel out the 2 charges here and here. So the formula for that becomes sodium aluminium hydroxide, which is what we've got there. Okay. And I'll talk more about the amphoteric nature of all of this stuff in the next one. So there we go.